All right, we're here. I'll start with this. This is great. Thank you for joining. Good morning, good afternoon, good evening, depending on where you are. I just got done, and I'm realizing that I have my wrong glasses on. But I just got done with basketball practice, but I've been thinking about this all day. I've been thinking about this all day. Last night, we got to hang out a little bit. We did a little stream. We were just kind of exploring. We had a question. My name is Sean. I'm a Spring Developer Advocate. I love my job and I'm happy to be here. With me, I've got Karen Beer. Do you want to introduce yourself? Like, let everybody know where you're from. I will say this before you do. I'm glad that we've met. I'm glad
Yep,
I run into your blogs. We've had a good time. Yeah, collaborating. And it's got to be at least a year. It's got to be, actually, it's got to be more than a year. Uh,
yep,
I'm glad that you're here. How about you
yep,
introduce yourself?
yep. I'm Karan. So I'm from India. I work in a company named Telstra, that is an Australian telecom giant. And I've been very tech enthusiastic, like overall, working on images, working on Spring Boot most of the times, some knowledge on Node.js and all those things. And I bumped into you last year almost coming up with a similar problem, and I was like, what is Paketo? What is this? What is that? And that was like a game changer for me. Like, okay, Raspberry Pi and all those things. And then, if you remember, almost 24 hours back, I again bumped into you. Like, I'm getting this issue. I got it on Twitter. Like, okay, this is the issue. And someone was linking, Sean knows it. I was like, man, I know this guy. Why should I not
Yeah,
go to him directly? That was the thing last night, and it was just awesome.
yeah.
And I've been playing around. So I had a GitLab runner that motivated me like from shifting to AMD 64 to ARC 64. So that is like the background of it. Uh, I covered up your intro part, but what was the problem statement? But
No, that's good.
ultimately, yeah, so that is it. I'm quite tech enthusiastic, running into problems almost daily. I cannot
Yeah.
sit with my day-to-day stuff and be like, okay, that is it. No, I have to be like something extra every day. Otherwise, it's a dull day for me.
Yep. Somebody said it to me, there, and the way that they said it, I want to capture it. The way they said it was like, you can't sit idle. Like you can't
Yep,
be idle because as soon as you take time and you're idle, the rest of the world flies by. Uh,
actually.
yeah. So, uh, hey, Franco, uh, absolutely. You will get invited. All I ask, like, hang out, hit the like and subscribe button. We got to be able to communicate. But yeah, hang out. We're on the Twitters. We're on the. I don't like Twitter so much. I'm on Blue Sky and communicate. Like, yeah, let us know.
Yes.
Subscribe.
Communication is the key,
Yes,
definitely.
and we'll get you. You got to tell us what you're interested in. But this is fun. Like we are here exploring. So here's the situation. We have these native images, and I can't afford the cloud. I have Raspberry Pis. I have a lot of them, and these Raspberry Pis, I've been a fan of them for a long time, and because of my appreciation for Raspberry Pis and my appreciation for Spring and Spring Boot, I really got excited when we brought the native images, the Graal VM support into Spring. And that happened in Spring Boot
Mm,
3 and Spring Framework 6. And it was a game changer. It absolutely made it so that we can deliver native images into much smaller devices. That's where I got excited. But just the native images by themselves, smaller footprint, faster startup time. Some workloads are like perfect for these
yes.
native images. And yeah, and here we are with Spring Boot 3.4.0. And this is just happy circumstance. We've now got a dual architecture build pack. So when you come out of the gate with Spring Boot 3.4, you can create images for both ARM64 and AMD64, which we've had all the time. But now you can do it for ARM64 with the same build pack. And this is a huge step. And what happened yesterday, Karen asked, could I've got ARM64. Could I build for AMD64? Could I build for x86 with my ARM64? And I was like, I know that people have done this. And over the years here, I've seen other people do it using emulation. QEMU is the one that I lean into the most. That's the one that I've seen. And I was like, yeah, let's try it. And we were just kind of both chatting at the same time. And we said, let's just do it live. So we started up a stream and we started working on it. And we found out, like, hey, we went through the process of showing Spring Boot 3.3, the build pack, takes a really long time. And on my older machines, it actually would crash and it wouldn't finish. And what we found out is like, hey, it's not always super fast, but it works. With Spring Boot 3.4 in this build pack, we can actually create images for both ARM64 and AMD64 on whatever platform you're on. And that's all we're going to do is we're going to review it. And look at this. Look at Sivas here. He says, you start getting older from the day you stop learning something new. Keep learning, stay young. Yeah, Siva said the other day, he's like, and this is, I think this is relevant here. There's only so much, there's only so high, so good that we can get at what we do. What we can do in order to be better, in order to level up, is you start leveling up the people around you. The way that
Yes.
Steve said it was much better, but it stuck with me and it hit me in my heart, and I'm going to keep on that one. I'm going to hold on to it because that's what we're trying to do here. Is we're having fun. I think this is kind of a front leading edge kind of thing. So we're here to show you how easy it can
Forever
be.
Young should be the song here.
Yeah, yes, it should. So I'm gonna be fully transparent. What we're not going to do today is we're not going to be on an x86. It's an AMD64. This is a machine that I don't use very often. It's sitting over there. I did this exercise on an AMD64 machine. I built
Mhm.
an ARM64 native image, but it took me 2 hours and 31 minutes. So
Quite huge.
there's a lot of things that were kind of counting against me. The screensaver went on, and it's using Windows subsystem for Linux. So a lot of things were kind of like stacked against me, and this going faster. We'll come back to that. It's possible. So on AMD 64, on my slow machine, I was able to build an ARM64 image in 2 hours and 31 minutes. And I can say from experience, I've never tried to do that before Spring Boot 3.4.0. I never even tried. I was always on an ARM64 machine trying to build x86 images. I never gone the other way until yesterday, until we validated that
Until
it
I
worked
triggered you.
yesterday. You showed me how to fix it. So maybe let's start there. Where we left off is we didn't know how to get the emulation going, and let's jump to our link.
Can I ask you a fun question while you just
Yeah,
start on it?
yep.
When was the first time you bought this Raspberry Pi?
20
Rough idea.
2016, I think.
Oh, wow.
2015
My
or
was
2016.
2014,
Yeah.
Raspberry 3 x86.
Yep. Yep.
It didn't came 64 that time.
Yeah. There you go. Uh, yeah. I You shared a link last night on how to set it up,
Yep,
and I'm trying to
it is a
find
Docker
it.
link.
Uh, and I think I have it right here. I gotta find it.
It should be on the general on your Discord.
Oh, yep. I'll go find it because that was nice. It worked, and I saw it. And there was another link too. Let me find it here. Here we go. I'm gonna put this link up. I'll put this into the chat. If you want to set up your machine to do multi-architecture builds with build packs, all you've got to do is set up your machine to do multi-architecture builds with Docker. So let's go to this URL and, oops, it went to the wrong screen. Sorry about this. I'm going to move this one. Oops, wrong one. I'm going to move this link down here. And this is the one. This is, if you run this, you will install all of the things that you need to install on your machine, no matter what platform you're on. It'll install all the things you need to install in order to run multi-architecture build packs. So what we're looking at here, this is the QEMU install. Like this is how we can do it. So let's just go and do that real quick. I don't need to on,
Best part of it was official, like coming in from Docker rather than some kind of a
yes, Because what I was
way
doing,
out
I had
industry.
some other scripts that I had done in the past, and I'm like, oh, hey, what are those?
Mm,
I don't know if they work yet. But on this machine, let's just see what that looks like. Uh, let's see what happens when we do that. So it installed all the things. They were already there, so there's not a whole lot of fluff here. But this says these are the architectures that we can build for. That's
yep.
slick. That's like, and we can actually, these are the ones that are supported, and we can emulate some of these others. So
Yep.
this is very slick stuff. What we're going to do, actually, we're not going to do it on this one. We're going to jump over here. Uh, and, oh, not even here. Oh, actually, let's go back there. Because I tried to do this again. I tried to get on maybe a faster machine. I tried to see if I could get things working on another machine. And let's go into that project. So I did the exact same setup. I made just a real simple Spring Boot 3.4.0. And what I was trying to do was the same thing. This is what it looks like. I'm spilling the beans. All we're doing is Maven Spring Boot build image. And we're saying, hey, we want a native image. What I'm doing here is I'm naming it. So I'm saying this is what I want the image name to be. But this is the part where I say this is the platform that I want to use. I want to use Linux ARM64 to build this image.
Yep.
And when I run it on this machine, so I'm doing this to see if anybody here has maybe run into this or knows what's going on. Because this is the same command that I ran over here on this other WSL machine, but this is what I ran into, and I spent a little bit of time on it, but I was busy today. But this is what I ran into. It didn't work on this machine, so I haven't replicated on any other machine, but so far so good. Like we can still go on. So that's what I ran into. We'll see if we can come back to that later, but I don't know the answer there. So let's go here. We're gonna go
And
to,
maybe you
yeah,
can use the command to
uh-huh,
also showcase like what platform are you on. Uname hyphen M,
yep,
I believe.
A,
That can
yep,
break that barrier
yep.
of knowing what are you on.
So I can see here, whoops, I gotta move this, that on this machine, I'm on x86, right? This is
Yep.
my AMD machine. Yes, good.
Yes.
There is also um, history pipe grep, you name. This is my test to know that I can run a different platform. I'm on x86, but what I'm going to do here is because I've installed the emulation, I'm going to
Yes.
run this image, this Alpine image, with ARM64, and I'm going to see what it says. CV, boom. So I just ran that same uname-a command, and this time it says, "Oh yeah, I'm ARM64."
Yep.
So this is proving that I'm emulating ARM64, and I'm able to execute
Yes.
that Linux kernel. That's nice. So that's all well and good, right? Anybody can do this. That's easy. We've shown the easy bits.
Yep.
So let's now, again, my computers are slow, so we're not going to play on those. I've got ARM64. Most of my area is ARM64. So we're going to go over here. And this isn't even my fastest machine. I should do it on a fast one. And actually, I'm going to, because yesterday we had a fast machine to do it on. And it was like reasonably fast. So I'm going to stand up this machine. And we'll terminal into it. I'll still be here. But we're going to jump into this other machine that has a little bit of battery left. It hasn't been plugged in for a couple of days. Let's go into that one. SSH into Traveler. And that's just my other laptop. That's my newer laptop that should be connected. There we go. And we're going to go into fun, Deshaun. Did I have a project here? I did. I already had a 3.4. But let's make a new one. Just, there's nothing up our sleeves, right? We're going to start from scratch, and we're going to do Spring Boot Start. We're going to build a new, this is using the Spring Initializer, but we're doing it from the CLI. And we're going to say, hey, we're going to call this, yeah, stream, Twitch stream. And we're going to use Maven and Java, and we're going to do it with Spring Boot 3.4. We'll leave it 0.0.1, and we'll leave the defaults. We don't need to change anything. We're just having fun here. But what we're going to select here is I'm going to go, I typed in web, and I'm going to select web, then I back up, and I'm typing the actuator, And I'm grabbing the actuator, and then I'm backing up and I'm typing native because I'm going to build a native image. This brings in the things that I need to do a native image. I hit enter, and then I hit jar, and we're going to use Java 23 because it's the latest and greatest, and it's awesome. And that's what we used yesterday. We don't have to, but it's got all the things, and it's middle aged, right? Java
Yes.
24 is going to be here in February. This is already like on the way down. So we're going
Mhm.
to use Java 23. Let's use it while we got it. So now we've got a new Twitch stream project, and we can just like make sure that it runs. MV and W Spring Boot run, and it's going to run. Of course, it's going to run because it's a demo. We knew it was going to run, and here we are. It's up. It starts. Everything's good, and we could actually even go over here, and we could say, "Hey, localhost 8080 actuator health health." What I do? Localhost 8080
It's on
actuator.
Traveler, so it will not
Oh,
work on this
haha.
machine.
Thank you for that. See, you're so smart. We did it. So it's up and running. We
Yep.
nailed it. And now this is why teamwork makes the dream work, because I was going to miss it. Look at this. How are you doing? What is the Spring Boot start command? I haven't seen that before. It looks cool.
Wow.
That's a great question. I'm a big fan of this project called Spring CLI. Let's pull it up. And actually, I think you have seen it. Miller79. I think you have seen it. I'm pretty sure I've shown this to you. So let's look it up, Spring CLI. And in fact, I'm going to double down. Wait, Spring CLI. It's this one. It's not the Spring Boot CLI. It's the Spring CLI, which it was actually kind of like incepted around the same time as Spring AI. You'll notice like some of the old Spring AI docs, maybe it doesn't do it anymore, but the Spring AI docs used to use Spring CLI to get started, and I guess they don't anymore. But this is the project. It has a lot of cool features. Let's take a look at it because it's worth it. You'll remember, yeah, you have, but we never asked about what. Yeah, that part. Yeah, we didn't talk about this part in particular. So if I do Spring help, this is a tool. It's an experimental, like it's got some versions, but the Spring team is overworked and underpaid. There's not as many people working on the Spring project as you think they are, and they got a lot of stuff, and there's a lot of demand. And this one's just kind of lower on the priority at the moment.
Yep. This release, the last release was on 6 months back or something. They
Yeah,
don't maintain it quite often compared to the other ones.
yeah. There's a lot of other things that have taken higher priority,
Mm.
but I'm still a
Yep.
fan of it, and I use it all the time. So
Yep.
here we can do AI add, where you can use AI to add things to your project. We can do Spring Boot add. I can add other projects. This is what you saw me do, Miller79. I can grab other projects and I can incorporate them into my existing Spring Boot project. And I can make my own commands. So I can add my own extensions to the Spring CLI as well. But what we did is we just did Spring Boot start. So all it's doing is calling out just this initializer at start.spring.io, and it's walking us through all the options. And it's very, very slick. So
The
here we
same
are.
question I had
Yep, same question.
firing upon you.
Yep, and there's installers. You can go and take it for a spin. There's some installers for
Mm.
Mac and for Linux. There's Debian
They
and
have
there's
a
Brew
good
and
amount of variants. Yep.
yep. So we have this thing. It starts and it works. And what we would normally do if I want to build an image, I would do MVNW. This is the way I like to build images. MVNW Spring Boot build image. I like to build my images this way because I don't want to write Docker files because if I write a Docker file, I have to maintain a Docker file. This way, I'm getting the latest build pack, and the build pack has a bunch of really cool benefits built in automatically. So I don't have to optimize my Docker files. I don't have to touch a Docker file. I got a command already given to me by the Spring team. So I'm going to use this. This is how I build an image. And this goes out and
What is
builds an
underneath
optimized.
this command? It is only relying on Docker, or does it need anything else?
So it needs a Docker.
Daemon.
Yeah, because what we're doing is with this build pack, we're pulling it down and we're running inside of that build pack, which is an OCI image. We're running all of this stuff. A
Okay, it's
build pack
via
has,
Docker only. Okay.
yep. So it's just Docker. Uh,
What if we do, okay. That's the different stuff. Emulation, it will just prioritize that emulation part, but
Yep.
it will be still Docker. Yep.
Yes. Uh, so we have an image, and we can run this image. If I do docker run demo 0.0.1 snap shot, I didn't have to do anything. I got a Docker image that runs.
Yep.
That's
Pretty
fantastic.
neat and awesome.
That's easy. I can push this. I can take it to wherever I need to go. It'll run on Cloud Foundry. It'll run on Kubernetes. It'll run on a Raspberry Pi. But the problem here is, let's go, let's do this. I'm going to leave that running over there. I got to go back to Traveler, right? And we're going to do Docker stats. Docker stats lets me see how much memory it's using. And it was the demo. Wait, which one is it? Let's look.
You didn't name it.
I didn't name it. So do I get to see what the name is? No. I should be able to see it, right?
Maybe we can use Docker PS and then figure out what was
Yeah.
the name of that image.
Exactly. Docker PS. Is this one Intelligent Dubinsky?
And then
Right.
DAD. Yeah.
Docker
Yes.
stats. So this guy is running, right now it's using 266 megabytes.
Yep.
Can't fit a lot of those on a Raspberry Pi 3B Plus because a Raspberry Pi 3B Plus only has 512 megabytes. So I can't run a lot of these. That makes it not as much fun. And this is a simple bare bones app. We didn't do anything. It's got some actuator endpoints that are listening, but we didn't do anything. And it's taking 266 megabytes. That's not fun for anybody. So how do we fix that? We make a native image. So let's do that. Let's go back over here. Actually, you know what we can do? We can do this. We can say docker run -d. And is it dash name or is it just dash name? Is it dash name?
Dash name. Yep.
And demo Java 23. Actually, I'm going to do it this way. So we're going to just leave this running in the background, dash name, demo Java 23. Cool. So now that's running in the background. We can say docker stats, and we'll see demo Java 23, and hey, it's running in 220. So it's just, we're leave it running. But what we're going to do now is I want a native image. I want an image that's going to start up faster, that I can, it's going to have a smaller image, but it's one that I can take to a Raspberry Pi. So how do I do that? Well, since Spring Boot 3 and Spring Framework 6, we could build native images, and we can do it. I don't have to do anything else. All of the projects in the Spring ecosystem that we deliver, they're all ready for this native image. MVNW, Spring Boot build image. And I'm actually going to give it a name. So I'm going to name this image separate from the other one. I'm going to say spring-boot.build-image.image name equals, we'll call it demo-native ARM64. -p, because we're going to now make it a native image. So I do p native. This is the trigger that makes it a native image. So I didn't have to put this image name here. We would have got a native image, but I didn't want to overwrite the other one. So we're going to get a new image called demo native ARM64. Let's go. On this machine, it's going to take about 38 seconds. On the machine that I'm streaming on, it usually takes like a minute. But this one's a little bit faster. That we're doing it on an M3 versus this M1. Apple Silicon, ARM64. But here we go. Because it's in a Docker image, because it's in a build pack, the build pack is pulling down a Ubuntu version. We can see here that the build pack is also pulling down a version of Liberica JDK that has the native image toolkit. The native image toolkit is what allows us to use GraalVM and analyze all that bytecode, convert all the bytecode down to native image code. Oh, and it's going fast. Much faster than the 2.5 hours that it took to build that ARM64 image over on the AMD. So far so good. This is going pretty smooth.
Yep.
oh, I was going to draw a picture. So, that took longer than normal. I apologize for that. But we now have this image. Let's see it. Let's see it run. We're going to say Docker run demo native ARM64 latest. And we're just going to run it like that. And look at how much faster it started up. Right? It was like a second on the other one. It started up in 0.044 milliseconds or seconds, 44 milliseconds. That's crazy. Fun fact is that 44 milliseconds, because it's running in a Linux Docker image, that actually is faster. We're gonna sidetrack, and we're gonna validate. I'm gonna do mvnw, and I'm going to say native compile. So all I'm doing is building a native image, but for Docker, I'm not using Docker, for Darwin ARM64. So this is going to build an ARM64 image for Darwin, this Mac operating system. So I can't run this on a Linux machine. What I built in the build pack was built with Linux, ARM64, and I can take that image, and because it's in a Docker image, I can run that anywhere that can support Docker.
Can ship it everywhere,
Yep,
yes.
but this one that I'm about to build, this one, I cannot do that. This one is optimized for Darwin, this version of the operating system, and this architecture. So
Correct.
these native images cannot be just willy-nilly, go across. Bytecode, write once, run anywhere. Native code optimized for an
Dedicated to the
architecture.
machine.
Yep. And here we go. We'll see if it takes.
Underneath, it is using what? Like when we use this native.
So what it does, it generates the bytecode,
Okay.
and then GraalVM is the tool. So yeah, I will
Okay.
draw some pictures here. So that took 33 seconds. But watch this. Do you remember how fast the Docker image started up? 44 milliseconds. Watch this. Target demo. $54 milliseconds. The native image running on Darwin actually starts up slower than the
Docker.
OCI, the Docker container. Isn't that wild? Josh discovered that. I had seen it. Josh is like, this is crazy to me.
Mm-hmm.
It's not Docker's, the addition of the Docker container isn't adding more than the Linux being a more optimal operating system. Linux, optimizing for Linux is more efficient than optimizing for Darwin. So even the trade-off of running a Linux image on top of Darwin is still faster than optimizing for Darwin. Is that wild or what?
That is actually wild.
And we were like, I don't understand, but it happens all the time. So on Darwin, and I'm not saying it's going to happen everywhere else, but here on these machines that we've been using, this one, I've got an M2 over there, I got an M3 right there. Same thing all the time. So let's go back and let's watch. 40 milliseconds.
Yep.
How wild is that? So now we've done it. Now let's do this. Let's say, hey, we're going to do this. We're going to run this one in the background. -D name. This is demo -native ARM64. Run in the background. Now let's go look at what these things do. Docker stats. We've got two images that we really care about. This one and this one. We had 228 megabytes that I would only fit one or maybe two of those on a Raspberry Pi 3B Plus. And this one is only 43 megabytes.
5 times.
That's amazing. That's a big difference. And not only that, it started up way faster. So this is our trade-off. This is why we like native images. Not for every use case, but for some. This is why we're exploring. Because if you've got thousands of these, or if you've only got a little bit of space to run these on, that matters. Because this image, this one here, it's still enterprise grade, production ready Spring Boot. Like it's still, my actuator endpoints are still there. I can still do all the things. It's still the same Spring Boot app.
And possibly throughput is greater than the
Depending on your
Non-native
workload, yep, depending on your
Yes.
workload, throughput might be better.
Yes.
So you at least have options, right? We can do this. I can go and I can do a load test against both of these side by side. I can decide which one I want to go to production with,
Correct.
right?
Yep.
How long? We've only been streaming for 30 minutes. Like, do you
That
have
would be
30 minutes
yeah, that
to
would be
go and
good
do
number
this?
of options for people. Like they can possibly to save money and non-prod. Maybe not prod. If they are not confident with this native image and prod, they
Okay.
can run native and non-prod. They can
Yeah.
save hell lot of money.
Yeah. Watch this. I don't know about you, but I like to run things locally. I like to see, I've got a little kind cluster here. So I can say canines. I like to have Kubernetes running locally. Now, the cool thing with native images, because they start out so fast, I can literally have hundreds of things that are here, but they're scaled to zero. Now, I don't on this machine, but I do on another one. Let's just show that. So in development, if you and I are working on the same microservice architecture, we've got a dozen different services. We got a modest laptop with 32 gigs. We got a modest laptop with 32 gigs or whatever we're working on. We might want to have things running, but we don't want it all running all of our resources. So what do? Let's go and let's look. What might we do? I'm going to go over here. Maybe. kubectx. Let's see. kubectx. We're going to switch to this cluster. And maybe I can do this. We're going to go down and we're going to look at javagrunt.com. And we're going to see. So in this namespace for javagrunt.com, there's only a few things running. The Cloudflare is running. The Zipkin is running for traces. We got stuff for logs. But it's just, there's not a whole lot. So there's three things. And what we're looking at here is pods, right? So all we're looking at is pods, and we're looking at for javagrunt.com. It's a simple machine. I don't want to run a bunch of things running all the time because there's no traffic, right? There's nothing there.
Correct.
But because javagrunt.com is not anything fancy, javagrunt.com, I'm willing to trade off. So I hit the button already. A little bit of trade off for it to load up because here it is. There's the service that started up to respond for that. It's only been up for 10 seconds. This is what we do. It's already deployed. I didn't have to deploy anything, but I had that service deployed and it was scaled to zero. And when it started up, I can actually even go look at it. Oops. Oh, it's already gone. No, here it is. Boop. This one. Oh, I want to see if I can get the startup time. So it started up in 0.279 seconds. I can afford for that thing to start up in 0.279 seconds because, like I said, I don't have cloud money. I got Raspberry Pi money. So I can have dozens of websites, dozens of microservices deployed on my laptop that I'm working on. Now, this isn't my laptop that I'm working on, but I could have them all deployed on my laptop. And when it comes time, hey, I want to see Karen's user service, I can hit it and it'll pop up and it'll start up in
Yes.
0.279 seconds and I can keep on working. That's a
Yes.
big difference.
Huge one.
But I don't want to do that
Oh,
with JVMs. So I use the native images to do that.
so you are hosting your Java Grunt on in your
I
own
host
house cluster?
everything in this room. Well,
Oh,
actually,
wow.
in this room and a room upstairs, because I've got two networks that are coming into the house, so I can do interesting things, right? So, yeah, I have two networks and they're balanced because, yeah, my children will never do active passive, like active all the way. Like a single failure is that's for the birds. It's 2025.
Yep. Yes.
One of us, one of us. Yes. So this is all done, and you can do it too, right? For something like this, you can do it on a Raspberry Pi. You could host hundreds of websites on a Raspberry Pi as long as they're not taking a lot of
Yeah,
traffic.
Cloudflare
Yeah. So
tunnel.
I did. I had cloud. Right. Let's look. I had Cloudflare D. So I don't even
Oh,
have a port coming into my house.
hmm.
I haven't opened up any ports. What I've done in this cluster is I've said, hey, Cloudflare D for javagrunt.com, I'm over here. And I did
Yep.
it on this cluster and the one that's in the other room so that it can be load balanced across.
Interesting.
Yes.
Awesome.
Easy peasy. But another
Yep.
benefit of these native images. Icon, I'm very glad you're here. I'm not on my Twitch stuff today. Todd Libby, I'm happy you're here. I need to go over here and shout out. These are some of my favorite streamers. So let me do this. Twitch.tv. And I'm gonna try to make it so that I don't do the Inception like echoey thing. Oop, there. Sorry about that. But I want to do is a shout out to, I'm gonna do Todd Libby first. Thank you so much for being here. I appreciate you. And yeah, and kisses from Paris, France. The fun thing here is like, I love it when you tell us where you're from because my mom and dad, they are always watching and they love seeing that. Yeah, I've got people coming in and hanging out from all over the world. So yeah, drop in, tell us where you're from. And this is good. We're making progress. So we built native images. We've shown some examples of why you want to build native images. But also, I'm on ARM64 most of the day, but my team is not always on ARM64. And if I want to give my teammates non-prod images to run, what if they're on AMD? They can't run this native image. It's Linux ARM64. So what do I do? What do I do? We don't worry, we take care of it for you. So in our same project where we were here, right? Our Twitch stream project. Now, what we did last time was we said, hey, just build me a native image. Oh, we did this Maven, this one. We're going to change it a little bit. Now, I want to build one for my friends that are using AMD64. So let's do that. Let's change this. We're going to say, no, not ARM64, AMD64. But I'm still going to build the native image. How am I going to do that? I'll tell you how we're going to do that. We're going to give one more parameter, spring-boot.build-image.image platform equals Linux AMD64. Now, on Mac, by default, the emulation was already set up. I didn't have to do anything on Mac. And it works really, really
Yes.
well. So let's go. I'm going to hit the button. And we're going to watch. I'm going to point out a few things. It's doing its thing. The build pack's going to do its thing. Now look at here. Where we downloaded this AMD64. It says, oh yeah, we're on AMD64. I need the AMD64 image. Let me pull down the right JVM for this AMD64 architecture. Right now, we're on ARM64. But we're
Yep.
using emulation and the build pack, because the build pack is a multi-architecture build pack, we told it, use the Linux AMD64 platform. So it pulled down that image and we're able to do the emulation. And now the process that it's doing, the optimization it's doing it for Linux AMD64 chipset. And man, it's going fast. I think yesterday it was like 4 minutes, if
Yes.
I recall.
Around 4 minutes.
So we'll see. So we got stuff
14.
to talk about.
Yeah.
I'll draw a picture. Xcaladraw.com is my favorite. Let's see if I can do this. Let's draw a picture. We've had this for a long time. Bytecode. Bytecode, write once, run anywhere. And that anywhere is anywhere that we have a JVM. JVM. We've got JVMs for all sorts, right? We got OS, Windows, Linux, 3BSD, Darwin, ... Architectures. Yeah, we've got ARM, it's supposed to be Arch, right? That's what we learned yesterday. Arch, x86, x86 64, AMD64, all pretty much the same thing. But also RISC V. What's the mainframe? It's ZOS. Should be up here. ZOS, the IBM mainframe. And what is their, I don't know, mainframe. So anywhere that I have a JVM, I can run that bytecode. No matter where I built it, the bytecode is set up to be delivered to a JVM. And that JVM then runs on top of an operating system and architecture. But all the way back with Java 1.3, at Sun at that time, they came out with the hotspot JVM. And what that did was it would look at that bytecode. The JVM would be like, oh, I see this little bit of bytecode that you're doing here. And it would take that bit of bytecode and it would optimize that bit of bytecode all the way down to the operating system and architecture, just like we're doing now. So your application is working. It's like, oh, wait, I don't want to do that. I want to jump down here. Let me execute it faster down here on the operating system and architecture, and then come up and then I keep on doing my bytecode. We've had that since the 90s. And it was the team over at Graal Labs that delivered Graal VM. And what Graal VM is doing, it's analyzing not just the hotspot, it's analyzing all of the bytecode and it's doing all of it. And what that means is that these images, right, when I'm building something, the layers of my Docker file, look, I got my app code, I've got my JVM, I've got my architecture, right? That's a typical thing. But when I do the Graal VM native image stuff, my image, those images that we just made, they only have native code and this. And they sit on top of the architecture. So not only does it use less memory, but I don't have to ship a JVM. So we got some new cool things here to go look at. So let's see. It took 3 minutes and 55 seconds like we saw it. We saw it yesterday, but we delivered an AMD64 image. If I go Docker, if I do this, I say Docker inspect this demo-native-AMD64 latest, we'll see that the architecture of this is Linux AMD64. Now I'll be able to run it here.
Same way, if you can show the Docker inspect for the other image, just to compare.
Yep.
That makes a huge difference that way.
Yep. Here we go. ARM64.
Yeah. So that is the difference.
We generated this, and the thing is, we didn't write anything to do this.
Correct.
On Mac, it's got the emulation already there, so you don't have to do anything. We showed you how to do it if you're on not Mac. On Linux, we showed you how to install the things that you need to install. That was here on this page, right? You can run this, and I found another command in order to do that, and I'll grab that because it also worked. Let me find it. And I got this, I'll be honest, from like ChatGPT and Claude, but it worked. And that is this. Boop. So very similar, the QEMU user static, but it just installs all the manual things. So this is just another thing that I got from ChatGPT or one of the bots. So you have another option. But these docs are great. Like, it's probably safe to do these. So here's what we're going to do. We have both of these images that were both made here. We're going to go one step further. Because when I say, hey, yeah, you're going to go ahead and grab that, whatever, demo, I want you to go grab that demo version. I'm not going to tell you what version to grab. I'm not going to tell you that I've got it for ARM64 and AMD. I don't want you to even have to worry about that. Just go grab this URL. So what we're going to do,
possibly someone who's not even aware of what is ARM64 or vice versa.
That happens. Let's do this. Doctor,
we don't want to be racist with the images.
Exactly. We're going to do this. Docker images, pipe grep demo. I want to do one more thing. I want to point out, I told you here in my picture, I was like, your native images don't have to ship a JVM. So these are going to be smaller to send over the wire. So on my laptop, I got a bunch of these native images. I don't have a bunch of JVMs in that image. So here's what it looks like. The JVM image that we made first, 259 megabytes, is the size of that image, that OCI image that I'm shipping to a registry. The others, 117 megs for this one, this AMD64 one that I built on ARM64. And this one, 111 megs. So
Less
that's a
than half
big
the
difference,
size.
right?
Yep.
That's a big difference if you're sending these across the globe. If you happen to work for a telecom, right? Right. And you have thousands or tens of thousands of these images running. These
Yep.
numbers matter. These numbers add up. And you're getting all of this for free. Like we didn't sell anything. We didn't have you install anything. You can do all of this for free. It might take you a little bit of time to run, right? It might take you a little bit. Oh, I lost it took us 2.5 hours to build it on a slow machine. It might take a while, but you didn't have to go and stand up any other infrastructure, right? You want to
Yep.
give your friends the latest game. You can build them an image and let them play it on whatever platform they're on.
It is a possibility. Like someone might be getting cheaper VMs based on the
Hmm.
other platform. And if
Yeah.
emulation is enabled,
Yep.
and then they do not care about the speed, they can wait for like 15-20 minutes. That's fine.
Yep. I want to show. There's one blog uh, that came out a long time ago. This one. Is this it? Yep. It was Liz Fong over at Honeycomb. I don't know if this is the first one, but 2020, yeah. So it's about that time. Hey, reInvent, they announced this Graviton ARM64. Blah, blah, blah. We decided to take it for a spin. Like, hey, here's what we do. Here's all the things. Let's TLDR. Let's go. Here's what happened. Heat map. We're doing things. Median latency. She made the switch, or they made the switch. Where's like the summary? There, one of these graphs was like, here's what we did. They were able to, as of today, we shifted 100% of our dog food shepherd workload to run on this Graviton ARM64 using 30% fewer instances. So they have 30% less machines
Wow.
handling the exact same amount of workload
So
just by switching the architecture.
ARM64.
And
Okay.
now, so
Oh,
what does that mean? That means that they just took the bytecode and they moved it from an x86 VM over to an ARM64. They didn't do anything else. They didn't do any of the other stuff. They just took the exact same bytecode and moved it to a different architecture. And they were able to, this is a benefit of the architecture, giving them a 30% savings. So same for same, number of cores, dollar amount for the VMs. They got rid of 30% of their VMs and they're handling the same
oh.
amount of work.
30%, even if it was 20%, then also it was huge. 30 is like one third, man.
Right? Right? For some companies, 10%. Right? There's companies that
That
are
is also
squeezing out
quite huge.
1% because that 1%
Yep.
on your multi-billion-dollar a year company, that 1% is a game changer. That lets you
Yep.
hire 5 more awesome engineers.
Yes.
Here we go. So this is what we've done. Now we've built both AMD64 and ARM64, and it'll work here, but it'll also work over on AMD64 machine that doesn't have emulation. But I want to go one step further. I need to pull up my cheat code because I did it in a repository. I used to do these Paketo build pack stuff. I had my own builder, and I've got a cheat code here. So here's what we're gonna do. First thing we're gonna do is Docker push. Or actually, we'll tag the demo native ARM64 latest. We're going to tag it to put into my repository. And demo. And we're going to call this one native ARM64. And then we're going to tag demo native AMD64 latest with this so I can put it into my repository. Demo native AMD64. Now we're going to push both of those. Docker push Sean demo native ARM64. We're going to push that up to Docker. Docker login. Oh, I'm on a different machine. I don't have all my stuff. Let's see if we can do this.
How much they have evolved, no? Like previously, you had to type your username and all those things. Now this is also
Yep.
another good thing
Okay, it says
from
fails to
Docker.
store tokens, error storing credentials. Maybe that didn't work. Docker login. Oh, what does it say? The keychain may be locked. Unlock it by running
Blockchain.
this. Oof.
Your system's password.
Yep. So maybe this. All right, we're in.
Done.
So now let's push. Fantastic. We can go make sure that it's there. Hub, Docker, and there it is. Fantastic. It needs a description. That's okay. But we can see, hey, it recognized it's ARM64. Now let's do the other one. I'm pushing these both up. And I'm doing this because I want to show, I want everybody to be able to see that we've got two different images that are there. And we're going to glue those images together into a single digest. It's going. All right, this is our non-platform. This is our emulated image. And it doesn't have a copy of it. So now we can go over here. I hit refresh. And I should see two images there. I've got a native ARM64 and a native AMD64. We're in good shape.
Yep.
Did it show the... Yeah, there we go. OS Arch. Cool.
Yes.
So now what we're going to do is I want to glue these into one image. If you're on AMD64, I don't want you to have to pull down the Karen demo native AMD64. I want you to just pull down Karen Beer demo. Here we go. We're going to do this. I'm going to look at my notes over here. I know it's Docker manifest. This is the key. Let's do it this way. I want to be able to show Docker manifest create, and then I give it the name Dashan, AARANBIR demo. Did I do that right? Yes. And we're just going to call this native.
Yep, native should be fine. We do not need any other.
And then we're going to,
reference.
in this manifest, we're going to amend two others. Dashan / Karen Beer demo, the native ARM64, and amend Sean demo native AMD64. Glue these things together. Done. Now we're going to say Docker manifest push this native. That's all we had to do. Now we've got a multi-architecture image. As far as anybody's concerned, it's a multi-architecture image. It's called a manifest But when you go pull, wherever you're at, if you're here in the chat, I want you to go pull this as soon as it's done. Because let's go back and look. We hit refresh.
No,
I've
it will
got,
be the other one. It's not Karanbir hyphen demo. It will be a new one. Just Karanbir.
yep.
Karanbir colon.
Oh,
Yeah.
boom. So here I've got native, but watch this. It's got multiple architectures.
Yep. It dropped down.
So we go back here. Here's our, anybody can go. Grab, do this.
Docker
Yeah, it'll
pull
be native.
dash flash Karanbir limited.
Docker pull Deshaun native. Boom.
I'm doing it on my ARM64.
Oh,
Let
yeah,
me.
we can do this because it's a different name, right? This is a different thing. So it's going to pull it down and let's take a look. Look at it's downloaded. Let's take a look at my Docker images. Oh, I'm going to make this prettier because I got a bunch of stuff here. And I have it. Let's do it.
0.57 on my
All right.
machine.
And then I do Docker inspect. Deshaun, Karen, native. And we'll see that it pulled down the right image. I didn't have to tell it which one to pull down.
Yep. Worked for me as well. Quite neat.
We did it. How do I?
This was the first kind of experience, this amend and manifest part.
We did it.
Yep.
We did it. This is fun. Thank you. This is
Thank
awesome.
you to you.
What does it say? I appreciate you use a slider to show the concepts you flip. It makes the differences to keep attention. Well, I thank you for that feedback. I'm glad that worked for you. I know that everybody learns a little bit different, but we did this. This was great. We built multi-architecture images, and you can do this with Docker, but friends don't let friends use Docker files. Like nobody wants to do that. We did it without having to write anything. We built for multiple architectures. And now that we've got ARM64 architecture figured out and x86 architecture figured out, now I've got devices over here that are RISC-V. That's the next step. We're gonna be able to in the near future. I don't know when. It's not on any roadmap, but starting now, we're gonna start working towards being able to build RISC-V images with Spring Boot 3.4 and beyond. In Java, and we're going to be able to take Java everywhere we want to go, even on little
Maybe
computers.
you can also tell like people, obviously with this feature, everyone would be easily moving on to 3.4. Correct. But what was the option that you did in 3.3 possibly? Like you had to supply the builder. That is
Yep.
something you had to do. But here, nothing, like
Yep.
almost out of the box.
Yeah. So let's just, for those that didn't know, for a long time, I was maintaining a build pack that we could use for ARM64. I had a bunch of other flavors. Daniel Makusa really helped out. I forked his repository, and then I wanted to maintain. So I kept on pushing out releases, and that was kind of the de facto build pack for people that wanted to build ARM64 images with Spring. And I felt pressure, right? Because there was people using it, and it was getting used all over the place. But now I don't have that pressure anymore. I learned a lot. It was great. It was a good learning experience, but now it's in such better hands. Right now we get it. There's no extra steps. You just get it. And you can not only build for ARM64, but you can also build for AMD64 on whatever machine you're on. You can target and you can build these images. And
Yep.
Josh, our friend Josh, one of the things that he said that's really, really kind of made an impact, and he's just so clever. He's so smart. He's like, it used to be that it was the machines at work that were the most powerful. It used to be that when you wanted to do some really heavy compute, you would go to the office and you'd run it in the data center and you'd run on those machines. But not anymore.
Yep.
Now, especially because of ARM64, we're getting this massive power on our laptops. Our laptops, a
Yep.
lot of times, are more powerful than what we're running in the data center,
And the
what we're
newest
running in
launch
the
of
cloud.
Mac Mini,
Yeah, I mean,
that
it's
is
it's
like,
amazing. Yeah, that M3
yeah.
that I did this example on, like, still, that's
Mm,
mind-boggling.
yep.
Mind-boggling how much faster it is. So it's a great
Yes.
time. It's a great time to be a Spring developer. Don't let your friends use Docker files. You have no need to use Docker files.
Yep.
Use build packs. And maybe, I have this other example. Somebody brought it up. They reminded me earlier today. And actually, there's been some stuff on Blue Sky. Have you heard of Graal Pi? Graal
Nope.
Pi lets us do the similar thing with Python. But wait,
Wow.
there's more. If you've got Python workloads that are running in production, but maybe you love Spring Boot and you'd like to do all the Spring Boot things, you want it to be not just like Python do its thing, but you also want it to be enterprise grade and production ready. You also want your actuator endpoints and your metrics and your observability. You want all the other things that you love with Spring. Graal Pi is the tool that I think brings those data scientists and the Spring engineers together. Because I can take with Graal
Mm,
Pi, similar to what we just did with Graal VM in the build pack, I can use Graal Pi to go and turn Python into native code. But Graal Pi also provides a polyglot API, meaning it's going to provide a hook for my Spring Boot app to call into that Graal Pi. Hey, I want to call that Graal Pi
mm.
method from my Spring Boot app. Hey, go analyze this image using the Graal Pi PyTorch image analysis, machine learning pipeline that you built. But I've taken that.
Dal VM team is doing quite brilliant. Like overall, like they had a feature to also run Node.js using Java.
Yeah,
I forgot the exact name.
yep. So they have this for multiple languages. Uh, where is the Node.js is just one.
Multiple languages, but
Yeah.
uh,
Where's the list of languages? Because they do for JavaScript for sure, Python, but I feel like there's more. Here we go. WASM, Ruby.
yep.
So this is the thing.
Someone
And
who wants an
those,
enterprise stuff,
with
they
all
can
those,
do
yep,
a
you
lot of
provide
stuff.
the polyglot API so you can
Yes,
interchange.
polyglot, that was the thing. Yep.
I can grab JavaScript, I can grab Python, I can grab Java, and I can glue them together, just like you would
Yes.
expect, right? Somebody that doesn't know computers, they don't know the differences in the languages. They would say, well, why can't you just connect to that thing over there? It's written a
Yep.
different thing. No, Graal Pi makes that kind of connection possible.
Possibly
Graal,
someone who's running a process which is based on Node.js and that
yes,
is stored in a database,
yes,
some script or something, or Python or something. It could be
yep,
anything. And like a heavy enterprise grade gateway,
yep.
similar to any famous one like
Oh,
Apache.
I I was trying to show this screen. Like I wasn't showing it. Like you can do this for multiple languages. Apologize for that.
Yeah. Yeah.
Yeah, Graal VM and Graal Pi. I didn't even show the screen. I was saying, hey, like this thing, Graal Pi, is amazing. It lets us do that, but it also for JavaScript, Python, WASM, Java, and Ruby, we can do this amazing polyglot interop.
Awesome people these are.
Yep. Yeah. Big fans.
It's
Big
on my hit
fans
list, maybe sometime,
of those teams. Well, we can do that next time. Next time
possibly.
we can come back. I've got some demos. I don't have it ready just yet, but I think I have a repo, GitHub. I think I have like a Hello Pi. I don't know where I put it, but I definitely have a repo. I'll bet you it's on this other machine somewhere. See, fun, Sean, uh, Hello Python. I mean, let's just see what it does. Spring Boot, boot, run. Oh, what did it say? No plugin. Oh, it's not a Spring Boot app. Anyway, we'll come back to it. Uh, I'm happy to show that. I've got a demo somewhere with Spring doing its uh, fun-loving arm hug
Fusion.
around Python. We can come back and we can do that on our next stream. This was
Yep.
fun. It's late for me. I
Awesome.
know you're just getting started. I want to say
Yep.
thank you so much.
Thank
And you know
you.
what? I'm gonna do a shout out here because the Karifi blog that you did, this one, this is the one that I always run into, right? When I'm doing
Hi.
my Karifi stuff, this is what we first, I think, our first interaction might have been around this stuff with Raspberry Pis. But this blog it's, thank you so much for doing that.
Yep.
Oh, I didn't share it. Again, I gotta put it on the screen. Like, hey, here it is. This is the one. This is your blog about setting up Cloud Foundry with Karifi, and it's a great little easy read. I appreciate it. Hey, Todd, we appreciate you too. And now I got to do a shout out that I didn't. I did Todd, but I need to shout out Icon too. Whoops, I did that wrong. That's the wrong person. We'll get that going. Yeah, Todd, thank you so much. This is fun. Check out this blog if you want to have Karifi running locally on top of K3s or something like that. It's slick. So now, again, we're gonna get out of here. This has been fun. Thank you so much, and I
Thank
look
you.
forward to doing it again. We're gonna scratch an itch. We're gonna figure out something like, hey, can we do that? And we're gonna figure it out together, and it's gonna be fun.
Yes.
Thank
Yep.
you so much, and thank you everybody for
Thank you.
stopping in.
Thank you.
This was fun. Have a good day. We'll see you soon.
Yep. Thank you. Good night.